Welcome back to second video, that is on CT crash course, that is on chapter electric charges and fields. Dear children, in the previous class we understood about introduction to matter, electric charges, their properties, okay, what is electric field, and also Coulomb's law, dielectric constant. We discussed it. In this class we are going to learn about first topic is that electric field and force of many charges. Let us consider a charge Q1, and there are so many charges are present in the system: Q2, Q3, Q4, Q5, Q6, dash dash dash, number of charges. So now here we know that Coulomb's law, that is K into Q1 Q2 divided by R square. Okay, we discussed in the previous class. Now for this force which is given by F12 is equal to K into Q1 Q2 divided by R12 whole square. So similarly I can write dash 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 F14 is equal to K into Q1 Q4 divided by R14 whole square. It means the total electric force in the system is algebraic sum of all the charges which experiences in the system. So it becomes, generally we can write that is number of particles is equal to Q1 divided by, that is Q1 into K. K is called, that is 1 by 4 pi epsilon naught. This is constant value, that is equal to 9 into 10 to the power of 9 Newton. Okay, we will use in the numericals. Now this is Qi divided by Ri square. Qi means what, children? I is equal to, it may be 1, 2, 3, any number of charged particles. So this is about force. Let us come for electric field. So what is electric field? The region surrounded by the electric charge. If number of electric charges are present, what is going to become? We know that electric field strength is equal to force per unit charge. Now it becomes electric field due to a charge. So we can take it as F means, that is K into Q1 Q2 divided by R square divided by Q. Now here sum of the electric forces means the electric field is nothing but the sum of the total electric field which is experienced by the individual particles. So we can write E is equal to E1 plus E2 plus E3. Now here one charge will be cancelled. Then electric field expression changes as E is equal to K into Q2 divided by R square. So I can write that is 1 by 4 pi epsilon naught, generally Q divided by R square. This is for expression for electric field, 1 by 4 pi epsilon naught Q divided by R square. Please note down, children. Now number of electric charges there means we can write K into summation of Qi divided by R square. In the previous case, Q into K into summation of Qi divided by R square. Okay, you can write in the form of unit vector also. Please note down. After this, let us come to the point electric flux. So the children, what is electric flux? So flux means number of field lines. Number of field lines. Suppose this is the area. The number of electric field lines which normally passes through given area, that is called electric flux, denoted by symbol pi. That is pi is equal to, it is also called it as, children, very simple, the product of electric field and area. If area increases, this pi will increase. If electric field is more, means electric flux will be more. Okay, so this is about electric flux. Remember this formula. And we can write formula, that is electric field means force per unit charge into area becomes Newton per Coulomb into meter square. This is the unit of electric flux. Come to the point electric dipole. Dipole means two poles are there, north pole, south pole. When I take two charges, plus Q minus Q, what is going to happen, children? The plus Q minus Q, so separated by distance, that is A. Now here, what is electric dipole? Two equal and opposite charges separated by small distance, that is called electric dipole. Okay, and this is about electric dipole. Again here, electric field means what, children? E is equal to, we written E is inversely proportional to 1 by r square. That is, we have got expression previous just now. E is equal to K into summation of Qi divided by Ri square. Now here, this is inversely proportional to r square. Now electric field due to along the dipole, that is at a point on the axial line due to dipole. So axial line means we are going to kind of horizontal direction. How the electric field will be there? That is given by formula E is equal to K into, that is 2 times of Rp divided by r square minus a square whole square. Just remember this formula, children. This is dipole moment. What is dipole moment? That is product of the charge and distance between the two charges. From here to here A, from here to here A, the total distance will be A plus A, that is equal to 2A. This is dipole moment. This unit will be, that is coulomb meter. Okay, now here, if the electric field, if number of charges are going to be considered vertical position, that becomes E is equal to K into R into P divided by, that is R square plus A square over to the power of 3 by 2. If at the midpoint, what happens here, distance will be 0, then it becomes E is equal to K into R into P divided by A cube. If this A neglected means what happens? At larger distances. Okay, if R is equal to 0 means that becomes A cube, children. At the midpoint of the electric field of a equatorial line. Vertical line means equatorial line. Horizontal line means what, children? That is axial line. Now that becomes, this is at midpoint. If A is equal to 0, then electric field it becomes at larger distances. A will be neglected. That becomes K into R into P divided by A cube. This is all about electric field, electric dipole. So next, electric dipole in uniform magnetic field. Children, this is uniform electric magnetic field or uniform electric field. Means electric field will be remain constant. Now, they are going to, here we are going to see two kinds of molecules. Polar molecules, non-polar molecules. Suppose HCl if I take, they are separated by small distance, HCl, NaCl, KCl, and they are called polar molecules. They have permanent dipole moment. Remember, children, they have permanent dipole moment because they are going to be rotated. So non-polar molecules, H2, like homonuclear molecules, do not have dipole moment. Hence they are called non-polar molecules. Now what happens, children? This is equal and opposite charges. The net force is equal to 0. Remember, the net force of a two charges in the uniform electric field is equal to 0. And torque is equal to Pe sin theta. Means P is dipole moment, E is electric field. If theta is equal to 90 degree, then torque will be maximum. If theta is equal to 0 degree, torque will be minimum. They will focus in the CET, children. Please note down these values fast. So later we come to the point Gauss law. Very important, children. What is Gauss law? So Gauss law, he told the relationship between electric flux and charges. So according to Gauss law, what is telling, children? Definition is very easy. The total electric flux passing through the conductor. Suppose this is the conductor. The electric flux means number of field lines which are easily passing through the unit area. That is called electric flux. Now he is telling that the total electric flux which is passing through the given area, that is pi is equal to total charge enclosed by this surface. Means if so many number of charged particles are going to be surrounded by that surface, then there you can find more amount of electric flux. So that according to this law, that is the total electric flux passing through the conductor is directly proportional to the total charge enclosed by the surface, and it is inversely proportional to 1 by epsilon naught times of this charge. This epsilon naught is equal to, that is 8.85 into Coulomb square per Newton meter square. Very important, children. pi is equal to q divided by epsilon naught. Now we understood about this. Now Gauss law means you understood. So that is, in a differentiation form we can write delta dot E is equal to, means this is called divergence of a vector. The divergence of a vector is equal to q by epsilon naught. This is condition for solenoidal. Even they'll ask in the NEET exam, children, and see the fixed question. This is condition for solenoidal. So next we will discuss about, that is, electric field due to a single wire, infinite wire, and infinite sheet. Very simple. Imagine a wire at a point P that is given by formula. Directly we can write, children, that is electric field is equal to lambda divided by 2 pi epsilon naught r. And second one is infinite sheet, that is, it is for linear charge density, this is for surface charge density. We will discuss now. This is given by E is equal to sigma divided by 2 times of epsilon naught. Now before, this is the directly formula. Electric field is inversely proportional to R for single wire and inversely proportional to epsilon naught for surface charge density. So now here we will understand for continuous charge distribution, means the total charges are going to be in the system. They are going to distribute in the system. That is called continuous distribution of charges. So how can we explain, children? Very simple. So this is Coulomb's law expressions. Just he may ask you directly problems, children. He will ask you problems. Just remember this formula. Please note down. Now, last but not least, continuous charge distributions. Dear children, continuous charge distribution means, I told you, distribution of charges in continuous way. So lambda, sigma, rho. If I take a single wire, the number of charges present per unit length, that is called, that is linear charge density, short form linear charge density, surface charge density, volume charge density, number of, that is, it is given by surface charge density is equal to sigma is equal to q by area, and this is number of charges per unit volume. So unit will be very simple, children. This becomes coulomb per meter square, coulomb per meter cube. So this is a expression for linear charge density, formula and definition, surface charge density, volume charge density. So now here in examination what he will ask, mention the expression for, in CT, electric field due to single charge density. Let us understand for three things. Last topic, that is in this class. So dear children, electric field due to linear charge density, that is, we know that E is equal to 1 by 4 pi epsilon naught q divided by r square. So first let us consider for linear charge density. That is, we know that q is equal to, that is, lambda is equal to q divided by epsilon naught, q divided by length. Now q is equal to lambda into L. This becomes E is equal to 1 by 4 pi epsilon naught. So it becomes lambda into dl divided by change in length, that is r square. This is for electric field due to linear charge density. Similarly, children, we can write that for a surface charge density. So surface charge density means what is here? Sigma is equal to, that is charge per area. It becomes charge is equal to sigma into dA. It becomes E is equal to 1 by 4 pi epsilon naught sigma into dA divided by r square. Similarly, we can write volume charge density. That is, we can write it is denoted by rho is equal to charges per unit volume V. So it becomes charge is equal to rho into V. So that is Q is equal to, we can write, that is electric field is equal to, due to volume charge density, which is equal to, that is 1 by 4 pi epsilon naught. It becomes rho into dV divided by r square. So this is all about first chapter, children. I hope you understood. Please, if you like it, like this channel and share to many students. They may get benefit from this. Thank you for listening. Thank you.